Good morning, everybody. It's a pleasure to have Hayley here. She has had a career which I wish I had had, because I did some early years of oceanography and marine geology at UCT, and then went off to do some far less interesting, but also very interesting things. Anyway, Hayley's career started as an undergrad at University of Natal, and a master's at University of Natal, and a PhD then in Cape Town, where she really became totally involved and is the expert on the underwater geology and the coastlines around South Africa. She's done incredible mapping work on the Agulhas Bank, which we all know is a major resource for South Africa as a whole, but also holds an amazing history of early levels of sea levels, and probably of human existence, because we have evidence of this around the coastline in the various caves at the Kelders, Blombos, um, Pinnacle, and further up the coast on the Wild Coast. And I think she's been able to tie this all together and pull it into a story, which I think makes an amazing, almost like I would call it like a mega Netflix story for the world, because it's something which we all need to pay attention to. And everybody touts the frightening words climate change, but this is climate change in action, and it just gives us some idea of what is happening, and there's not much we can do about it. So let's just all behave ourselves, get rid of our plastic safely, and that will do the best we can.
Thank you so much, John, for your kind words. Yeah, thank you so much, everybody, for coming this morning. And I'm really privileged to come back to the OGG. I always enjoy being able to come out here and spend some time with you. Um, Today, I'm going to take you on a little bit of a ship trip from a voyage that we did now almost a year and a half ago, last year, at the beginning of 22, where we were doing deep drilling for research purposes into the deep ocean basins. So it's a little bit removed from the area that I'm usually working in, but to bring some context and some relevance to here, I'll definitely weave in how it relates to our coasts and our continental shelf, sort of as we move forward. So, yeah, for a little bit of context very quickly before we sort of dive into the deep sea floor, I just wanted to show a map of the South African continental margin for people that are not too familiar with it. So South Africa was centrally positioned in the supercontinent Gondwana before it broke apart. So before the Atlantic and the Indian Oceans existed, we were very much landlocked. Obviously, a very long time ago in any sort of temporal terms. But when the supercontinents of Gondwana broke apart, the Falklands Islands were actually situated up against what's now KwaZulu-Natal. And when South America pulled away from Southern Africa, it sheared off that eastern margin to make it very steep and very narrow. And then there was sort of a drift action towards the south, which resulted in this very wide southern continental shelf and a very wide passive western margin as well, which is why South Africa has that sort of imbalanced looking continental shelf fringing our coasts. My colleagues and I at the Council for Geoscience, we map the seafloor. We follow on the work of André du Plessis and his colleagues from the 1960s, 70s, 80s. Those methods in marine geoscience mapping are improving all the time. So still, it remains that you can't use remote sensing techniques from space to map the seabed. There's nothing that can be done remotely yet. Even in this world of artificial intelligence and machine learning, we still have to mount sensors on a boat and steam up and down, and we call it mowing the lawn. And the reason for that is that electromagnetic waves, such as those emitted from satellites, they cannot see through seawater. So only what's visible optically can you map from space. If it's not visible optically, you have to use sonar and other methods to do that. So there's no technology yet for an automated kind of a process, but the instruments that we use are improving all the time. And in fact, I think in the next few years, you'll hardly see people on ships doing this work. We have these remote controlled systems now where we operate them from an office. It's completely mind-blowing. But we're able to image the seafloor in amazing resolution, sometimes to decimeter accuracy. So if a tire has fallen off a ship, we've often imaged things like that on the seabed, ladders, all sorts of funny stuff. So the methods that were used in the past are the same methods that we're using now. It's just that the resolution is a lot better. So when we map the seafloor, we sample the seafloor, sometimes by scuba diving, sometimes by coring, sometimes by grab sampling, all kinds of methods. But these work on the continental shelf, sort of within the range of where a human being can go scuba diving, even if we sort of push that to its edges, it's not particularly deep. And of course, coring and dredging and grab sampling are very much determined by the water depth and how possible it is to sample what you're looking for. Sometimes you have to step right out of that and you actually have to drill the seafloor, which is a whole nother method completely. And we very rarely have those opportunities to do that in South Africa because our ships just aren't kitted out to do this. Generally, it's the oil and gas industry that would drill the seabed, not really the research industry in South Africa, because obviously we're a little bit cash strapped in our funding. But at the beginning of last year, the IODP, or the International Ocean Discovery Program, which used to be called the ODP, or the Ocean Drilling Program. A lot of people know that name. The Joides Resolution Ship came to South Africa to do this project, to drill the seafloor, after about 10 or 15 years of proposal writing and motivating. And this was a really special opportunity to sort of sample down through the layers of our stratigraphy in deeper water and in deeper time as well. So this IODP focuses on climate and deep life, planetary dynamics, and geohazards are their main themes at the moment. Of course, it's all to do with ocean exploration because we know more about the planets than we do about our own seafloor. So the IODP is a consortium of countries that fund this. South Africa is unfortunately not part of it. In fact, none of the African countries are part of it. We're in sort of conversations quite loosely about possibly joining and benefits of that, and costs of that, of course. But at the moment, we're not part of it. So because we're working in local waters, I was invited on board and part of the project as a local sedimentologist, a local geologist, and also officially as an observer, because you need that on board when you're working in anybody's territorial waters. But it was a real privilege to be part of the scientific team for this project. And it's certainly going to give us several years of work, and it has done so already. So to show you some images of the vessel and how things work, because it's quite interesting to people who don't often get their feet wet in these sorts of environments. The Joides Resolution it's a pretty long ship. It's about 160 meters long, I believe. The derrick, or the drill rig section, is about 70 meters high. And they often equate that to stacking 20 African elephants on top of each other. You know, so it's quite an impressive structure above your head. On board, there are fully equipped laboratories. It's almost like a floating university in a way. The labs there are totally mind-blowing. All the things that we do onshore, making thin sections, running geochemistry, even ICP-MS geochemistry, those are all possible on the go on this amazing ship. It uses dynamic positioning to remain relatively stable. So, sensitive instruments aren't going to topple off the counters. And of course, everything has to be very strapped down, even on small boats. It's always the case. What blew my mind was watching everything be loaded on board when we were waiting on the quayside. And we went out for 8 weeks. There was 8 weeks of things like onions and tomatoes, and amazingly, lettuce was still being served into week 6, which that also I found completely crazy, that the refrigeration was so sophisticated. I've put in a few little videos and just walking through the lab section. So this is where we did most of our core description work, and I'll show you more images of this later. But there are X-raying machines, core splitting machines, core storage facilities on board. So like I said, it's totally fully equipped for everything that you have to do. And by the time we finish up an expedition and hop off the ship, everything is already pre-organized. The samples get sent off later, but there's no sort of scrambling around and trying to organize sediments or anything after the fact. So marine geologists are very familiar with the topography or the bathymetry of the under the water part of Southern Africa, but not everybody is, of course. So just as a map with some of the names of these features, it's showing the Mozambique Ridge, which is like another Drakensberg under the water. Very deep channels on the other side of it. The Agulhas Plateau is point number 12. And the Transkei Basin is point number 13. And those two places are specifically where we went to poke these holes in the seafloor that I'm going to talk about today. Thinking of the Earth as the massive recycling machine that it really is, we also have to take into account in a marine context what's happening in the water column and how these currents have changed through time, because they do. It's very much determined by plate tectonics and the position of the continents, but it's also got to do with all sorts of other factors that operate in different climatic regimes, for example. And we're able to study these in the past. So right now we're familiar with the warm Agulhas current flowing down our eastern margin and the cold Benguela current flowing up the west, and how they meet and interact in the middle. But these are very much surface processes. And if you had to take a cross-section through the whole water column, you'd find that there were counter currents below that, for example, flowing in very opposite directions and pulling sort of different temperatures through the water mass around the globe, and very much controlling global climates and ocean chemistry, atmospheric chemistry too. South Africa has a very long history of having cores and drill holes and things poked into our seafloor. And a couple of years ago, I made a database of what was known at that time, in 2021. All of the black dots on the map are positions where core samples exist, which I think is quite impressive. I think that there's quite certainly a lot of sampling that's been done, but there are also big blind spots. There are areas that have never been sampled. And it's very exciting to be able to go and do that. And I've put a note here that the first seafloor samples were actually taken in the 1800s on the Challenger expedition, which I think is quite remarkable. Obviously, after the Second World War, when technologies improved, sonar was starting to be used to sort of see submarines, and sea mines and things like that could be flipped down to map the seafloor. The way that we do marine geoscience changed drastically. So in this specific expedition, which was 392, 392nd expedition of the IODP, the work was aimed at a couple of different things. One of them is looking at the tectonic history of this African Southern Ocean gateway. So what happened after Gondwana broke apart. The other one is the timing of this large igneous province, which is the Agulhas Plateau. It hasn't really been dated and studied. But interestingly, this approximately 100 million year age is similar to many other large igneous provinces in other ocean basins around the world as well, like the Ontong Java Plateau in the Pacific. So geologists are not entirely sure what triggered these massive eruptions of magma at those times, but the Agulhas Plateau will hopefully be able to help solve some of those unanswered questions. Of course, we're interested in the bottom currents and what information they left in the sedimentary record of the seafloor as well. Because as ocean water is swirling around, of course, it's moving sediment with it. It's either building up consorite drifts, or sometimes it's eroding them away if the currents are powerful at any time. And then the last question was about paleotemperature, because we anticipated that there'd be over 100 million years of stratigraphy in our deep ocean basin of Southern Africa. And this is a fantastic opportunity to study what happened after the Cretaceous Paleogene mass extinction that wiped out the dinosaurs. The Earth has gradually been cooling since then, actually, if you sort of zoom out and look at it on a sort of broader time lens. But it's a good opportunity to figure more out about that. And not much work in that regard has been done in this part of the world. So in the end, in 8 weeks, we drilled 4 holes, because it takes incredibly long. You have to position the ship in the right place, send down all the drill string, set up the headgear on the bottom, and then, of course, the drilling process takes long. And the deeper you go, the longer you take to retrieve these samples. So there are approximately 2 weeks spent at 4 different sites. And those are shown as yellow dots on the map behind me. How to know where to core is something very important, and that's where geophysics or hydroacoustic mapping is extremely critical in any of these marine sorts of studies. So first you map and then you sample. It's definitely the best way around to do things. And in this case, this area has been studied extensively over the last 20 or more years, particularly by Gabriele Unzelmann-Neben from the Alfred Wegener Institute in Germany. She's contributed a lot of knowledge and information on what's happened with these current circulations through time and the tectonic history of this part of the seafloor. So through her work of deep seismic, she was then one of the principal investigators of this IODP proposal that then went and drilled through what she'd already mapped with her students and her teams. We had 28 scientists on board and probably more than 100 crew to run the ship. So, of course, you live in quite close quarters for 8 weeks and work shifts. And it's sometimes you bump into somebody weeks into the thing that's on an opposite shift and you had no idea that they were even on the boat. You think you know everybody, but it's not always the case. The Joides Resolution Ship has got capabilities for 3 different types of drilling, depending on the kind of substrate that you're in. There's drill capability for sort of soft sediments, muddier stuff, then hard rock as well. So it'll change out according to what's required. So what happens with the sort of the workflow is that cores are drilled, they're brought up to the deck in these very long 9-meter sections. They're then carried and split into 1.5-meter sections to make it more workable. Those are split in half. There's an archive half that almost immediately goes off for description, but not really touching it. And then it gets archived. The working half gets sampled on board. And there are labs that are analyzing those samples as they're coming up. So there are people doing paleomagnetic studies. There's even people studying the microfossils stratigraphy on the go, determining the age as you go along, which I think was quite fascinating to see and be part of. I took another little video of people, the techs on the ship bringing these long core rounds onto the deck. Often they're very cold, especially because the ocean water down there can be about 2 or 4 degrees sometimes. And this just shows how they sort of clean it off and chop it up. And everyone's anxiously waiting to come and get going on whatever responsibilities they have. So these are some of the laboratories. I was on the core description team, which was really, I think, quite exciting because I got to see everything that was coming out. I wasn't just receiving any subsamples to work on. We were logging these cores. We were also using these instruments that measure porosity, magnetic susceptibility, and other geophysical properties, making sort of logs also on the go. This is just showing how one of them work. Obviously, the instrument goes along the core, making sure it misses nothing. On our description team, we had to replicate things in paper piles, and I think by the end, the paper pile was almost as tall as most of us were with these core logs, because there were hundreds of kilometers of core material by the end of the 8-week expedition. I'm going to talk about something called the green stuff just now, which is what we called it, but it was quite funny that on one day when we were mapping these particularly green cores, we all happened to be wearing green clothing as well. Of course, because it was the sort of end of COVID, we had to wear masks for the first few weeks of being out at sea, just to make sure that there wasn't any trouble with that. So when we're logging these cores, we're noting drilling disturbance as well as all the sedimentary structures and features. Looking at bioturbation and macrofossils. So these are ionoceramids, which were big clams that lived mostly in the Campanian time in the Cretaceous. It's about 100 million years ago. One of the cores also punctured through an ammonite, which was quite fun. And there was a lot of sort of burrowing and invertebrate structures left behind, such as this Zoophacus shown on the left, which makes a sort of a spiral-shaped burrow. The sedimentary structures were fascinating. Even though you were so far out, there was quite a lot of turbidite material, which means that there's still settling that's been determined by what's happening on land and how the sediment is making its way to the seafloor. And I'll loop back to that later as well about how we're going to correlate that to some structures along our coast today. There were things called smear slides that we were making from these sediments that you can quickly look at underneath the microscope. Thin sections as well were being made on board, which blew my mind. A lot of course, discussion about things. And you can see in one of these pictures how one of the core sections is really green and then immediately it's orange. And that was where this green stuff very abruptly ended at one of the sites. So again, I said I'll come back to that later, but we're starting to think now that it might be a weathering product of these large igneous provinces, and that it may actually be that large igneous provinces are influencing geochemical weathering on the seafloor across many parts of the globe. Some of the key things that we intercepted through these cores were the Oligocene-Miocene transition, the Paleocene-Eocene boundary, or the PETM, which I'll come back to just now, the Cretaceous-Paleogene boundary, which is very exciting to geologists. In fact, we got that in 3 different places. And yeah, there were thick sedimentary sequences that we're now able to study. This is very busy, but just to put these events that I've just mentioned into context, in the last sort of 65 million years since the Cenozoic period started and the end of the Cretaceous, when the dinosaurs and 75% of everything else went extinct, I said earlier that the Earth has actually been cooling, relatively speaking, since then. There are several tectonic events that took place that have determined the way that the globe looks now and the way that the continents are positioned, and also the way that the ocean basins have opened up and formed. And these were the opening of the Tasmania-Antarctic Passage near Australia, and the Drake Passage near South America, and the closing of the Panama Isthmus. So the two Americas came together, and that separated these three ocean basins, or four, including the Southern Ocean that we have now. And in this time, of course, the sedimentary record has kept pace with these things that have happened and can teach us about what's happened in the past. At the time when the Indian and Atlantic Oceans opened, about 130 million years ago, this was the Cretaceous, and terrestrial environments were quite probably different to what we know now, particularly in the Cape. There would have been a lot of cycads and ginkgos and conifers and ferns and funny animals, a lot of them that went extinct at the end of the Cretaceous, unfortunately. But because of that event, it made way for the rise of mammals and basically allowed us to exist the way we do now. Seeing this in core section, what we look for are normally hard contacts between different units, which would indicate change of some sort. We could determine from the microfossil experts if there was a gap in time or not. And often these were continuous with a hard surface, especially at the time of the mass extinction event, which is great. And in the picture on the left, within these 1 million years, shown by a few meters of core material, this is when the Antarctic ice sheets arrived and grew. They were not there before that. The Earth was very hot during the Cretaceous time. There was probably no ice anywhere on Earth. And if you had to melt all the ice on Earth right now, sea level everywhere would probably rise by about 65 meters, just to give you an idea of that. So the Antarctic ice sheets only appeared about 33 or 34 million years ago. We weren't there prior to that. We've also seen the Paleocene-Eocene thermal boundary, which was a very warm period after the mass extinction that happened 65 million years ago. It was also a smaller extinction event that took place then, but it only wiped out about 35 to 50% of a lot of the sea creatures because of this warming ocean. And that's also an interesting analog for us today to know what can happen at a worst case scenario. Then, of course, the Cretaceous-Paleocene boundary, which is very distinct, shown by this abrupt change from pale green into different colors above and a very hard layer. And like I said, there was no hiatus there. So it's not like there was a gap in time and then a different kind of sedimentation. The response to that was quite, not immediate, but in geological terms, quite immediate, probably. To show you what some of these snapshots of the cores looked like, this is one of the cores from the Agulhas Plateau. So the large igneous province area and the sediments that have built up against it. This was 630 meters of core drilled below the seafloor, and the water depth to get to the seafloor was 2,500 meters. Also on the Agulhas Plateau, this reached about, this is in the Transkei Basin. Just over here, so offshore of Gqeberha or Port Elizabeth, several hundred kilometers out, due into the Transkei Basin. The water is very deep, so it was 4,500 meters of water. Then we managed to drill another kilometer down onward from that. It basically used up almost all of the drill string on the ship because it has 6 kilometers of drill string available. So that was quite exciting. This one was very shallow, only 58 meters, because it went directly into the bedrock, into the basalts, and the drilling was quite tricky. And then I'm going to go back into some pictures. I got to log the KPG boundary, which was very exciting. The igneous petrologists were very excited to find beautiful examples of chill margins on the basalts and also dolerite sills, probably associated with this large igneous province. They were able to sample them for dating, and they're busy with that at the moment. A lot of manganese nodules and things like that that have grown around some sort of a nucleus, like in the middle. Yeah, just very interesting geology. These are some of the basalts with, like I said, lovely chill margins, pillow basalts, basically. And that can give an idea if it's subaerial or subaqueous. It's where the hot magma has met the cold ocean water and it quickly cools. And you get very microcrystalline crystals because of that. So extremely fine-grained basalts, like a little onion rim around the way that basalt would normally behave. Yeah, like John said, it's almost like glass. Obviously, being on a ship for 8 weeks, you have to live very differently. So it was a dry ship, no booze. I was saying to someone earlier, it was quite a cheap date when I got off the ship. But it's quite interesting to see how adults behave. I mean, we still had just as much fun. We had one opportunity for a little bit of a dance party, and we had such a jaw, which was nice to know that you can't do that without anyone having anything in there. You share a cabin with somebody who's on the opposite shift. So these are 12-hour shifts, noon to midnight. And the other person sort of works back to back with you. You can only take a tiny amount of luggage. I mean, there are washing machines and things on board, but probably about 4 changes of clothing and pretty scrappy clothing. So you don't want to mess up, any fancy stuff. So it's a completely different way of existing. Of course, there's massive crews of people cooking and working and doing all of those things to make it as comfortable as possible. There's a gym on board. But yeah, it's quite different to normal life on land. About 130, so about 100 crew and 28 scientists. Yeah. There was also a social media outreach officer on board who was constantly uploading what was going on onto the different social media platforms. Thank goodness, because a lot of us are not good at that and don't want to have to be thinking about that. So it was nice that there was a dedicated person just for that. She's also actually started a project. We all had to write haiku on different parts of the core, and she's putting them together into some sort of a massive stratigraphic log at one of the museums in the US, and maybe putting those into some sort of a book publication, which I think was quite fun. Sometimes the sea got really big, really rough. And of course, when you're pegged into the seafloor, you've got to pull everything out and try and balego away from that. So the one night we had sort of 12-meter swells, got away just before one of those big cold fronts. But yeah, it got quite interesting. Strap everything down.
So are you getting the whole reef back making symbol?
Amazingly, they do. Amazingly, they can line up with their dynamic positioning and the ship positioning, and the drillers are excellent. And somehow they did. I know, absolutely blew my mind. And the drilling methods on this ship are still quite analog. They're not these digital things that are used in the fancy oil and gas operations now. So the drillers are really, really skilled people. Yeah, that was scary. That was really incredible to witness that. Also, of course, it could be very beautiful. We had lots of time on deck between our shifts. And then bringing it back into the relationship to the Cape Coast. So, this is all interesting, but it's so far removed out there in the deep sea. So I was thinking of just discussing how that relates to what we know and what we're familiar with. So in the Cape, of course, we have our Cape Folded Belt Mountains, beautiful mountains that are very much exhumed, eroding incredibly slowly. They're one of the slowest eroding landscapes in the world, which is why we have 400-million-year-old mountains that are almost of like alpine scale, and those are about 4 times younger than the uplift of our Cape Fold Belt. So we have this remarkable environment around us. But in fact, when these rocks that now form the Cape Fold Belt were formed, the package of material was probably about 6,000 meters higher. So our mountains would have possibly been comparable to the Himalayas. And when Gondwana broke apart and the oceans opened, all of that material got shed off from the hinterland and made its way down into these newly formed ocean basins that had just pulled apart and just been opened from the moving of the continents. So most of the material from the top of the Cape Folded Belt now sits on the seafloor, and it's filled in these sedimentary basins since the Jurassic or the Mesozoic time through the Cretaceous. So if we want to know what's happened onshore, we have to be able to correlate that with the rest of the material that's now offshore, if that makes sense. So a lot of these very deep gorges and things that have been cut into the Cape Fold Mountains, this is near Prince Albert, Meyringspoort as an example, has been carved by a lot of uplift and subsidence, crazy tectonism that's not happening here now. So because of these motions and because of the removal of all of this material, these deposits that we then drilled were able to be drilled at all. And to look at this geologically, the blue and the green is the Cape Folded Belt. And then the oranges and yellows are younger sediments generally. And most people are familiar with the shape of the coast and the look of the coast and the geology on shore. Of course, as a marine geologist, we're always trying to see below the water. So we know that on the Agulhas Bank, the geology out there is very different to the geology on shore. So the Cape Folded Belt doesn't extend very far out onto the Agulhas Bank. Most of that eroded material was deposited there instead, which of course, even though it's the same material, it's much softer because it's in its crushed form. So we have a very soft substrate forming the Agulhas Bank from the material that was the rest of the Cape Fold Belt Mountains once before. And an example of this is on a rare clear day near Mossel Bay, standing on the cliffs near Cape St. Blaise. I could see through the water to some extent. The visibility was great. You can see how these rocks terminate very close to the coast. And our mapping work has shown that that is in fact the case. It's not just that they're buried by sediment. They're actually abutted almost immediately by these Mesozoic deposits that are then draped with seafloor sediments now. So the point is that there's a very different environment out there because of these ancient processes that have taken place. And in the Mossel Bay area, generally the work that I've done and presented on here in this context has been about just the last few 100,000 years and how humans have used this landscape through time. And the Paleo-Agulhas Plain is the submerged landscape under the sea. And it's there, and it looks the way it does because of these older geological processes that came before. So again, looking through the water column, with methods of sonar, we can see through the water column like dolphins and whales and bats can do. Humans have mimicked those technologies since the Second World War. And you can see in this bathymetric image that the Agulhas Bank is quite soft compared to other things around where the mountains do extend out. And interestingly, on the west coast, there's some very impressive canyons. And not everybody knows about these. So off Saldanha Bay, for example, there's the Cape Canyon, which actually drops down to 3,600 meters of water depth. And actually, it's almost the size of the Grand Canyon, but nobody can see it because it's down there under the sea. So these processes have shaped these continental margins in fascinating ways. In the last few 100,000 years, since we've been in our present cycle of climate that we understand it, where we go between ice ages and periods of warming pretty rhythmically, sea level has dropped to a maximum depth of about 130 meters relative to the present. And that's what opens up these landscapes that are now under the water. And in fact, on the Paleo-Agulhas Plain, we figured out that there's a landscape under there, a terrestrial landscape, the same size as the country of Ireland. And of course, in these last few 100,000 years, our early ancestors, Homo sapiens, were using that environment, occupying coastal caves and moving out onto that now submerged landscape, probably tracing this coast back and forth. And that's what our modern mapping methods are being targeted at, understanding a little bit better at the moment. So this is the sort of a plains landscape that's very different to the Cape Mountains as we know them now on the immediate offshore Paleo-Agulhas Plain. It's made sense in terms of archaeological records that have always had these bones of grazing animals. And it's been a bit of a puzzle, like where were they living? Because there's no environment for them right now, other than maybe a very small patch of the Agulhas Plain between Bredasdorp and the coast. That's a tiny snapshot of this much bigger under the sea landscape. We also find evidence of trackways, footprints belonging to animals that moved across these dunes and beaches when they were there as dunes and beaches that are now cemented into rocks in the last few 100,000 years. And my friend and colleague, Charles Helm, has led this work, looking at the paleoecology from a whole different point of view. So these are not just the bones that made their way into archaeological sites of animals to give you an idea of what was there. These are footprints of things that people would never have hauled back to a cave, like Cape lion, elephants, giraffes, all these sort of, we call it our Pleistocene game reserve out there because it's along the margins of the Paleoegalis plain. We can find these rocks with extra evidence of what that environment might have been like. Just some examples here are hominin trackways. We found quite a few of those now, actually. Lion, rhinoceros, elephant, extinct longhorn buffalo, crocs, all sorts of interesting things. And in fact, this time last year in Walker Bay, I found a trackway of a giant Cape buffalo, which is shown there on the left. And cross-cutting it was this funny linear shape that Charles immediately said, those are nice footprints, but what's the long thin thing? And I said, oh, I don't know. And then we did some photogrammetry 3D modeling, and he realized it was a puff adder trackway. Yeah. So when it was a sand dune, a puff adder slithered over the dune, and then a giant Cape buffalo followed because the buffalo track is over the puff adder track. I don't think those animals obviously intercepted. Thank goodness for the buffalo. But yeah, it was quite a fascinating snapshot of a moment in time from about 80,000 years ago. We've just published a paper on that. And there's a little article coming out in the conversation, maybe even today, about it, because people think it's quite fun that there's a snake track. It's actually the first snake trace that's ever been documented in the geological record. So between Walker Bay and Woody Cape, which is at the edge of the Addo Park, the Eastern Cape, so it's the from Walker Bay to the eastern end of the Cape Folded Belt, we've actually documented more than 350 of these different track sites over time. So the point of the looping back to this is just to say that these Cretaceous deposits that we drilled in the very deep sea floor are definitely connected to what we recognize on our landscapes here now. They've also determined the way that the Paleoegalis plain looks because they've formed the basis for everything. It all starts with the rocks, then you get soils and plants taking hold and animals and people, and you put a full picture together. And that picture could look any way whatsoever, depending on what the substrate geology determines. So these onshore, offshore connections, I think, are extremely interesting. And one of these onshore, offshore connections is looking at, in the Transkei Basin, I'm particularly interested in those turbidite deposits we kept seeing, because those are being shed off from what's now on land, made their way to the seafloor when the ocean was opening. And I think that those little pulses of deposition can maybe be linked to old seismic events, for example, and we're going to see how we can do that, try to understand a bit of a seismotectonic history as well. So in the way that we'll do that is that I'm doing a lot of work with some of my friends and colleagues in Mpondoland, the northern part of the former Transkei. We have a lot of information on that landscape now in cave records, and to have this unique opportunity to compare that to a very deep borehole drilled on the seafloor a few hundred kilometers out, I think is quite remarkable. We also, the geochemists that were on the ship, Alison Tesson specifically, has been figuring out the green stuff and the way that this weathering is working, what's driving it, because that was quite bizarre. And in fact, when she did more of a literature review, we realized that there's funny green materials often appear in these deep drilled boreholes. So she's just submitted a paper where she drew on most of us in the scientific team's information that we collected on the ship, and that's in review. So the work from this ship trip of a year and a half ago is starting to come out into the scientific literature. And we're also planning to do some cartoons and kid comics and things around how we study climates in deep time. Turbidites are soft sediments that, so if you had to cut a slice through the whole continental margin from the coast to the deep abyssal plain, energy decreases from the coast outward. So you get the coarsest, highest energy things closest to the coast, and the finest grained materials are able to make their way to the deep ocean basin. And turbidites are specific sedimentary packages that are very gravity determined in the way that they build up. So in one turbidite sequence, you'd have the coarsest stuff at the bottom and the finest at the top. And then as soon as that depositional cycle stops and a new one starts, you have another coarsest at the bottom and finest on top. So you have these little slices, like a layer cake stratigraphy. But those have been possibly, there was something that drove the input of that sediment onto the seafloor. So if you think about, I think last year there was a big dump of sediment out of the Congo River, and it was actually recorded because of the oil and gas operations there. And geologists were able to almost see a new turbidite in action and how this actually worked, follow the plume out So these sorts of things would be analogs of that in the past. Yeah, and on the ship, they always have, on the ocean drilling program and the IODP, there's always a drawing or a painting or a graphic design, something to sum up the voyage, and everyone has to submit something. And I scribbled a picture, and mine got voted as the one that they chose to keep on the wall of the ship forever. So I think that's quite fun. We saw lots of squids and lots of green stuff, and that's what I popped in there. So thought I'd show you that. All right. So I'm going to end there. Thank you very much.
Could you find oil and gas in your research as well?
Well, if we'd been looking for that, then there would have been different things being applied. But of course, through the geochemistry that they were looking for traces of hydrocarbons, and wasn't in an oil and gas expected area. But deep in the Transkei Basin, there were some more organic things starting to appear in core records, but very deep down. So I think it's, at the moment, as well beyond what would be economically feasible to explore much further than that. But yeah, certainly in these age deposits, that's always something that could be there. The large igneous province was the basement of the large igneous province, those basalts on the Agulhas Plateau. Yes. So that's the oldest material in that part of the seafloor. Because as the ocean opened, the lava would have come up. Yeah, it's ocean, mid-ocean ridge basalts or something. But yeah. So that's a large igneous province. So that's a massive injection of lava in the form of basalt flows and sills and things that came up in that area. So that would be basement to that area. Maybe John can explain this.
The ocean floor is generally full of these very extensive basaltic provinces, where basalt comes and spread. But then, what we're looking at here is a massive sort of wedge continental material sitting out there sort of on top of that base. But most of the ocean floor is essentially basalt.
So these were basalts too on the Agulhas Plateau. So there's probably a marine large igneous province intrusion rather than an extension of the Mozambique Ridge or something.
The drilling itself, I've always been fascinated by the fact that you say it's stabilized, but I've never really been able to picture it myself even. Like there's a swell. Are there enough hydraulics involved? Is it like an independent rig that goes up and down with a cylinder? How does it accommodate to stay fixed drilling while the swell is going up and down to that extent?
There is definitely a little bit of flexure and movement, and that's accommodated into the way that the drill strings and everything are designed. But on the ship, there are normally about 4 or 6 thrusters that are let down when you reach your position, and the thrusters sort of work in parallel to keep the ship as stable as possible. It's a really clever technology. So when you're drilling and the thrusters are being used, it's very noisy, especially down in the cabins. But the sea around you can be moving and you're relatively stable.
The technology is amazing. I mean, don't forget De Beers now have 7 mining vessels operating at 120 meters, lifting diamonds off the seafloor off the southwest coast of Namibia. And their last vessel, which was commissioned last year, the Benguela Gem, cost them $460 million, just the vessel. And then they fitted it out with the plant in Cape Town, and it probably got to 500 million. That vessel, mines on our west coast, where what the westerlies do. And that vessel, I think, can carry on till the swell is over 8 meters, and it will be, like Hayley's saying, an absolute pinpoint. The thrusters and the GPS positioning is just remarkable.
I've got great respect for it, but I still don't understand it fully. 8 meters of movement vertical, and the string is on top of that, and so something has got to move in relation to each other.
Well, there's a whole lot of compensatory processes. I mean, your drill string has movement in it. It's not just solid string. And there the bears mining either with a caterpillar on the seafloor or a big cookie cutter, like a biscuit.
No.
And that technology, I have a video on that vessel, and I'll circulate it to people, and you see the technology. It's just amazing. And I think there are two things that come out of Hayley's talk to put life in perspective. What's happened in the Western Cape here in the last couple of weeks is almost insignificant to sort of the history and the geological record she's showing, in that presentation. And it's the sort of stuff we see in our geological record. And correct me, Mike, you can, I mean, when you talk about turbidites, go to the Tankwa Karoo. We have some of the amazing exposures of turbidite sequences up in our Karoo, obviously slightly older. But again, you see these geological processes keep going round and round. The Earth is not static. So the Tankwa would be a very good example. And if any of you are diving through this, talk to us. We'll give you, Mike can certainly give you examples of where to see it on roadside. And the other thing, we geologists tend to come under a lot of stick for, being destructive to our environment. Well, most geologists that I'm aware of are actually very environmentally conscious. Yes, mining has left legacies. But if you see again the technology that they use, the cleanliness of those operations, the professionalism of those operations, and we know right at the moment, and Ralph might want to comment, there's been an authorization given to drill up a deep borehole, again, about potentially 4 to 6 kilometers down on the edge of our shelf to look for gas, which is a clean energy provider. Not perfect, but clean. That would be a game changer for the Western Cape, the Northern Cape, and probably the Eastern Cape. So the amount of effort made by geologists, engineers, these marine operators, the cleanliness, the attention to detail, and the attention to our environment is significant. And I think it's a point we tend to miss. We just geologists, we make a hole in the ground. That might have been the case previously. It's certainly not the case today, and it's something we need to take note of.
John, Gillian Falgo wants to know, what is known about the deeper structure of the Gallus Plateau? How thick is the crust?
The thickness of the crust in that particular place hasn't been mapped, but if you look at the Gallus Plateau itself as a topographic feature on the seafloor, it rises up at least 2,500 meters. So it's at least that high, and we don't know how deep it goes below that, actually.
But just tell Gillian, she's looking to come out here next year with the team, and those are the sort of questions we're going to ask her.
Gillian, you heard that? Then there's 2 comments from John Rogers. He says the turbidite and the Tygerberg Formation at 3 Anchor Bay, page 183 in his book. For those of you who want to start up, I just wanted the non-geologist to know what the turbidite is like. And then he says Hayley's drawings are on our geoheritage plaques at Chapman's Peak and also east of the Langebaan Lagoon.
Hayley, what did you discover that was fundamentally new?
Sure. Well, Gert, I would say that the only thing that was a real surprise was that green weathering. That was something everyone went, what is this? We're scratching our heads over that. The paleoclimate record that we intercepted, we were really stoked to get all of that preserved in these boreholes because we weren't sure that that would all be there, of course. So we've got this beautiful, almost complete picture of the last, certainly throughout the Cenozoic and even into the last part of the Cretaceous. So the last 65 million years, and in fact, the last 100 million years. So it wasn't a surprise necessarily, but we were just really happy to intercept all the important events that we went out to look for. And I would say the only weird surprise was the weathering that's going on so deep in the seabed. And also, what surprised me as a core logger was seeing the bioturbation and how deep that went. These hochos are way down there. And I think that they're still operating down there. It's not like necessarily paleobioturbation. That fascinated me a lot, to think of all the life that's now in this sandwich of sediment and rock.
Julian wants to know, how certain is it that the plateau is igneous? And if you just quickly, igneous, the crowd is not geologists in.
Igneous rocks are volcanic rocks, lavas.
How certain is it that?
Well, it's been very well mapped by Gabrielle Inselman-Neben, and in 2014, she invited me on board another ship trip where we dredged it in different parts of the plateau, and all the rocks that came up were igneous rocks and manganese nodules, which are secondary, of course. And that's different to the Mozambique ridge to the north, which has a lot of continental crust on it. So this seems to be mostly a, ocean floor basalt, large igneous province, all igneous rocks. Yes. So about 100 million, 105 to 95 million. But then palynologist, a pollen specialist on the ship who was working through the pollens and the cores, found evidence that some of the sediments on top of the plateau were possibly laid down subaerially, so not under the water. So there may have been a time when the Agulhas Plateau was exposed to the air before the sort of ocean filled in the way that we know it now.
Do they have will you have a date out of the basalts? That's somebody working on.
Yes. So there are igneous petrologists on board that are dating them. And there were dates done on the dredge samples from 2014, which gave that sort of rangefinder age.
What were
105 to 95 million. So, yeah.
And just to put that in perspective, and we want to do a field trip there, we should think about it. The Ganto Pass, if you're going down to Lowry, so we get sort of down where they've done the recent rock baskets, look up your right, there's a little gully going up there. That pass is where the elephants and the animals actually, in our early foot trackers, got through and up the what's the pass called? That's the Lowries. Then if you go across to Llandudno Beach and go to the east side of that beach, there's the most gorgeous, it's probably about 30 meters wide, dolerite dike of 130 million years. I think John's probably described it as well.
Logies Bay.
Yeah.
The one at Logies Bay.
Yeah. And it's beautifully exposed. And we want to go and do a field trip to the Cape Sea Point Contact, where Charles Darwin looked, and then go across. We can have lunch on Llandudno Beach. So we'll circulate to everyone if you're interested. Because we have some, like Katie's been saying, all this amazing geology around us. The second thing, just to add, Hayley's staying here this afternoon and this evening. So with us, if anybody wants to talk to her and get some further insight, you're most welcome to join us. We'll find somewhere for a meal this evening as well. But there she's a wonderfully hospitable, enthusiastic. And just to put things in perspective, so Gondwana land, this amazing continent of ours, broke up at about 180, 160 million years on the east side, and that's when Antarctica and Australia and that spun off, and it broke up and pulled apart at about 130 million years on this side, and we have all these amazing volcanics, the dolerite dikes, the Edendeka basalts in northern Namibia, and the Edendeka basalts match perfectly to the Paramar basalts on the other side of South America. So, so these ages of about 195 million years are clearly older or younger, than that tracker. And 65 is a fascinating age for the extinction of the dinosaurs, just to give you a reference point. And if anyone's going past Golden Gate at any stage, get hold of Gideon Groenewald and get him to take you on an excursion to look at those dinosaurs. They are some of the most remarkable fossils around that sort of age in that part of the world and older.
Maybe in those courses that you took in the basin, is there any indication of anoxia in those courses? You talk about bioturbation going right down as far as it went.
There is a person that's working on that, but to be honest, offhand, I'm not sure what those values look like.
Do you think you were distal or proximal in those light bands?
Probably quite distal for most of the time.
So
because
fine with it.
yeah.
Yeah, just thinking about anoxia, adding to that sort of possibility for package.
We didn't see any obvious markers like that, but I know that sort of values of organic material were getting a little bit higher in the geochemistry samples, but very deep down. So there was nothing sort of surprising in the upper layers.
Hayley, this ship was obviously purposely built for this kind of work. What is it doing now, and will it be coming back to this area?
Well, it's shifted away from this area now. So after our voyage, or maybe before, it was working off Namibia on the Walvis Ridge. And then it did a transect up the Atlantic back into the Northern Hemisphere. And I believe right now they're working off Greenland. But you can follow the Joides Resolution. They're really good with putting information online on websites and Instagram and all that stuff. Twitter, they're constantly uploading what they're doing, what they're finding, keeping people engaged and interested.
Are they going to come back?
I don't think anytime soon, because these voyages are planned years in advance to coordinate a path that makes sense. So I think that it's in the north now. Probably means it'll stay in the north for the next while, but I don't know offhand.
Seeing marine geologists comment on that. South Africa used to be one of the leaders in marine geology and oceanography. And people like Eric Simpson, I mean, courtesy of Hayley and some of her colleagues, they're keeping that up. But Andre, you might comment. I mean, at one stage, South Africa was a key player in that offshore research.
Yes, it did strike me, somewhere in the. I was trying to get the Earth magnetic field at the magnetic observatory in Mars. I've got to know magnetics very, very well. And things have gone by. So about a year or so ago, I decided, I better go and see what's happening at the space agency. And a little bit like my experience today, I understood very, very little. And then right at the end of the tour, I thought, there's a museum. So I went in there, and there I knew everything that was going on.
And on the other hand, I so wish I could have been part of your early discoveries where you went out there not having any idea it was on the seafloor and everything was new. I mean, that must have been so exciting. So that's what we long for.
One or two more comments here. Dylan says that the North Atlantic experience is that some of the plateaus could be lava-capped continental rocks. Yeah. And then John Rogers wants to know, is anybody studying the manganese deposits?
Not at the moment, John. Not in this area. Of course, in other parts of the world, people are very interested in manganese nodules at the moment because of possible future deep seabed mining. To map those out is very important. But these were not necessarily sampled for specific work on this trip. And I don't know of anyone in Southern Africa that's studying the manganese nodules now. I know that you and Mike Watkies were probably the last people that did that in South Africa. That's, not that I know of right now. And then Gillian, thank you so much for that comment. I'll definitely check that out. Thank you.
You said it was an Iceland day. A final comment from John is that Moesten Klanga of the University of the Western Cape has completed a recent MSc on the Sea Point contact, being published in the Geological Society of London book right now. Earlier paper was 1946 by Walker and Montia. Anybody wants to question up on that one? Thank you. Okay. So last question, baseball.
That's the International Ocean Discovery Program. Countries put money in to be part of it, 21 countries. And the amount of contribution depends on the sort of the economic state of the countries. So obviously some will pay less than others. Most of it, I think, is from Japan, the USA, and Germany. That's where